Our next lesson is on representing functions as rules and as tables. So we're going to talk about what exactly a function is. So when we talk about data pairing, typically we're talking about relations. And if you think about it, it makes sense because when you pair data, it's a relationship between two things. So one example I might use is I might say, does somebody's height correlate to their shoe size? So if I use their height as the first variable, and then I correspond that to shoe size, would that be a function or not? Well, in that situation, it would just be a relation because while we're relating two pieces of data, one's not necessarily going to have a bearing on the other one. Now, a function, on the other hand, is when the first set of data is independent and it determines the dependent, which is the second set of data. A set called the domain or the input numbers. And then there's a set called a range with the output numbers. Now, the input numbers or your domain are going to be your independent variable. And the output numbers, also known as your range, will be the dependent variable. Okay, so we have our domain, which is our inputs. And these are also known as the independent variable. And then we have our range, which is the outputs, and this is also going to be our dependent variable. Okay, now the way I remember this is that, first of all, input and independent will start with the letters IN, so it's pretty easy to kind of match those together. And of course, so those two go together, that's my domain, and then the range is your outputs or your dependent. So if you're identifying a domain or a range, it's very straightforward and simple. The domain is just going to be those input values. Okay, and then the range is going to be those output values. Now, if I want to write down my domain, I'm going to write the numbers that are my inputs. I'm going to put them in order from least to greatest, separated by commas. If you have any number repeated in your set, like for example, let's say I had a 1.5 and then I had another section in my chart with a 1.5, I wouldn't need to write it twice as long as it's included. And then some kind of grouping symbols, whether they be brackets or parentheses or something to just say that these numbers are contained within this set. The range then would be your outputs. And again, you're putting them in order from least to greatest. So I have $7.80, then $11.96, $16.12, and $21.82. And again, putting those in some sort of a grouping symbol to indicate that they're all contained within that set. So if we were to do these two examples here, my domain would just be 2, 5, 7, and 8. And I'm going to contain them in these funky looking grouping symbols. You might see something like that sometimes. And then my range is 5, 11, 15, and 17. Same thing for number 2 here. My domain is 1, 3, 4, and 7. And then my range would simply be 2, 8, 11, and 20. So before we move on, let's talk about a couple things here. So just to reiterate, the input value is called the independent variable, and that's your domain. And then the output variable is called your dependent, and that is your range. All right, so one of the harder things to do, or at least so we can understand what these pairings look like, is to tell whether or not a pairing is a function. So like I mentioned before, if you had height and shoe size, that might be a pairing of data, and it would be considered something called a relation because we're maybe taking the same height and shoe size from different people, so each person has their own pairing, but it may not necessarily be a function. So in order for it to be a function, each input can only have one unique output. So if I input a 1 into my equation or my problem or my function, I'm going to output a 15. If I input a 3, I get a 20. If I input a 5, I get a 15. If I input a 7, I get a 20. Each of my inputs only had one output. So this one is a function, yes. So now if we take a look at number 4, okay, my input of a 5, I get a 5. If I input a 6, I get a 5. If I input a 7, I get a 5. If I input an 8, I get a 5. Now, even though it might look strange because every single number that you put in gave you a 5, each number only had one solution. So the solution for my input of 5 was 5. It just so happened the others gave you the same solution. So this is still, yes, it is a function. Now, if we look at the next pairing in number 5, this time you'll notice that there's a repeated input. This is your first clue that something may not be a function. So if you have something doubled in the input, okay, if every input only is there once, then it's going to be a function. But if you have an input twice, so you have 12 and we're inputting that 2 different times, every single time you input that 12, you should be getting the same output. It's like you substitute a number into a math equation or expression, you should always get the same answer. If you're getting a different answer, it's probably because you did it wrong one of the times, right? So in this situation here, we have the 6, which gives you a 3, and the 18, which gives you 2, but we really don't care about those because we don't have a second 6 or 18 to even compare it to. But we do have the two 12s. Now the first 12 outputs a 4, and the other 12 outputs a 1. So because there's 2 different answers happening here, 2 different outputs for the same input, this is not a function. Okay, so now we're going to go back to the other page and we're going to talk about how to make a table, a function table. So first of all, we need a function to draw a function table. And a function is basically like an equation, but it's a specific equation where we know each input will only have one output. So my function equation here is y equals x minus 3. And then they're giving us the domain, which is 2, 5, 8, and 11. So notice those are already put into our table. So the x values that we're going to be using are 2, 5, 8, and 11. So then what are we doing? We're going to substitute those in for the x and find our range values. So remember, the domain, which is your x's, if I substitute in a 2, try this again here. If I substitute in a 2, 2 minus 3 is negative 1. For the next one, I'm going to substitute in a 5. 5 minus 3 is 2. Then I'm substituting in an 8. That gives me 5. And then the last one, I'm substituting in 11, and that gives me 8. So then you can see that my range of this function would be negative 1, 2, 5, and 8. So let's try a couple of those. So now we're going to make a table for these functions, and then we'll identify the range as well. So the domain is already given to us. So once again, I'm just going to go ahead and put those numbers in my chart, 0, 3, 5, and 7. And then I'm going to substitute those inputs into my function where the x is and find my outputs. So really all I'm doing here is multiplying 4 by each of these inputs. So if I input the 0, 4 times 0 is 0. If I input the 3, 4 times 3 is 12. If I input the 5 over here for my x, 4 times 5 is 20. And if I input a 7, 4 times 7 gives me an output of 28. So my domain, which was listed, and now I have my range, which is 0, 12, 20, and 28. All right, let's take a look at the next one. Again, they're giving us our domain here, which is 1, 2, 3, and 4. I'm going to input each of those in for my x here into the function. So 3 times 1 is 3, and 3 minus 22 is negative 19. Now I'm going to input a 2. 3 times 2 is 6. Minus 22 is negative 16. Now I'm going to input a 3. 3 times 3 is 9. Minus 22 is negative 13. Input of 4, 3 times 4 is 12, minus 22 is negative 10. So my range is negative 19, negative 16, negative 13, negative. Okay. Before we move on to writing a rule, let's just see if there were any other examples that we might want to make a table for. So same idea whether the table is horizontal or vertical. So in this example, our domain, we're just going to go down vertically for our table instead of horizontally, but it's no different. Here is our function rule that we're using. So 4 times 1 is 4, minus 2 is 2. 4 times 2 is 8, minus 2 would be 6. 4 times 3 is 12, minus 2 is 10. 4 times 4 is 16, minus 2 is 14. So that would make my range 2, 6, 10, and 14. And of course, you could continue to do that with these other examples here, but it's still the same process. Okay. All right, so now let's talk about writing the rules for the functions. Okay, so writing a function rule is basically trying to come up with an equation for this chart or this table. So just like we did before, we had y equals, and then we had to do something to these input values to get those outputs. So we want to figure out what is it that we can do to the 3 to get to 15? Or what can we do to that 6 to get to the 30? What can we do to the 7 to get to the 35, and so on? So 3 times what would be 15? 6 times what is 30? 7 times what's 35? 10 times what's 50? Do you see any sort of pattern there? Well, I know that 3 times 5 is 15. 6 times 5 is 30. 7 times 5 is 35. And 10 times 5 is 50. So that tells me my rule is 5 times whatever my input was, which is going to be represented by my x. And you can always double check it. 5 times 3, 5 times 6, 5 times 7, and so on. So this would be my rule. 5 equals y equals 5x. All right, so let's try a couple more of those. For this one, they appear to be increasing by 5s. So that's giving me a hint that I may have a 5x involved there. So now let me try my inputs. 5 times 1 is 5, 5 times 2 is 10, 5 times 3, and then that pretty much checks that one off for us. Okay, next one, we're adding 1 each time. So y equals 1x, but 10 to get to 3, I'm going to need to subtract 7. So 11 minus 7 is 4, 12 minus 7 is 5, 13 minus 7 is 6. So that's our rule for that one. Offered at night, the fee is $12 per lesson, and you plan to attend up to 5 lessons. Write the amount you will spend as a function of the number of lessons. So it might be easier for you to work with a table. If not, you don't have to do the table, but it might give some people a little bit of a visual. So up to 5 lessons means you could do 0, 1, 2, 3, 4, or 5 lessons, right? So up to 5. So the fee is 12 per lesson. So if it's the X, in this case, is the lessons, and then the Y is going to be the total cost. So the lessons, you could go anywhere from 0 to 5, and the total cost could be anything from $0 if you don't do any lessons, or 1 times 12 is 12, 2 times 12 would be 24, 3 times 12 is 36, 4 times 12 is 48, and 5 times 12 is 60. So what was my equation? Notice as I figured that out, I was just multiplying each number of lessons by 12. So my rule here would be y equals 12x. Of course, my domain in this case is 0, 1, 2, 3, 4, and 5. Now, when you have a situation like that where the numbers are going in order. Sometimes you might be able to shorten that up a little bit. Like maybe you can just say like um, all whole numbers greater than 0 and less than or equal to 5, something like that. But since we can't have decimals or fractions of less than, I'm not going to really do that. And then for our range, we have 0, 12, 24, 36, 48, and 60. And let's take a look at one more. The table shows men's shoe sizes in the United States and Australia. Write a rule for the Australian size as a function of the United States size. So we want this to be the Y and this to be the X. So it looks like the sizes are increasing by 1 here. So it looks like we're taking the US size and we're subtracting 2. And that gives us the function.